Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Analyze each option for pi electron count. A. Cyclopentadenyl anion, 5-membered ring, negative charge. The ring has 4 pi electrons from 2 double bonds plus 2 pi electrons from the lone pair on the carbanion, giving 6 pi electrons total. 6 is equal to 4, 1 plus 2, so n is equal to 1. This satisfies Huckel's rule and is aromatic. B. Cyclopentadenyl cation, 5-membered ring, positive charge. The ring has 4 pi electrons from 2 double bonds, and the carbocation contributes an empty p orbital, 0 pi electrons, giving 4 pi electrons total. 4 is equal to 4, 1, which satisfies the anti-aromatic condition, 4n rule, n is equal to 1. This compound is anti-aromatic, not aromatic. C. Cyclopropenyl cation, 3-membered ring, positive charge. The ring has 2 pi electrons from 1 double bond, and the carbocation contributes an empty p orbital, giving 2 pi electrons total. 2 is equal to 4, 0, plus 2, so n is equal to 0. This satisfies Huckel's rule and is aromatic. D. Cycloheptatrienyl cation, 7-membered ring, positive charge. The ring has 6 pi electrons from 3 double bonds, and the carbocation contributes an empty p orbital, giving 6 pi electrons total. 6 is equal to 4, 1, plus 2, so n is equal to 1. This satisfies Huckel's rule and is aromatic. Moving on to the next step. Option B. The cyclopentadenyl cation has 4 pi electrons, 4n, n is equal to 1, making it anti-aromatic, not aromatic. And for the final step. Why other options fail to be the answer? Options A, C, and D all satisfy Huckel's 4n plus 2 pi electron rule and are therefore aromatic compounds. Therefore, the correct answer is B. Therefore, the correct answer is option B.